We're turning now in this section to the topic that was mentioned earlier, communications and neuroscience research by scientists and journalists. We've got quite a panel. I've had a chance to chat with several of them. And so we look forward to hearing from all of you. The first is Dr. Ushma Neill. That was close, I hope. She will start off and is the director of the Office of the President at Memorial Sloan-Kettering Cancer Institute, serving as chief of staff and the center's president and to the center's president and CEO. Editor-at-large for the Journal of Clinical Investigation, having previously served as the journal's executive director, and as editor at Nature Medicine. She's also chief editorial consultant to the newly launched journal, Molecular Metabolism. Welcome. We're interested to hear from you, eager to hear from you.
Thank you very much for the chance to address this very august group. If you don't mind, I will read my comments so that I can make sure to keep to time. So science and research are built on a foundation of integrity and truth. And over the course of my 13 years as an editor, I found that the overwhelming proportion of scientists do operate under these principles and present only proven and replicable data. But given the intense pressures scientists face in a harsh funding climate, there's an ever-present need to produce results, and specifically to produce positive results that support a central hypothesis and result in a high-profile publication. Unfortunately, this intense pressure to publish or perish has led a few unscrupulous scientists to present doctored data, and this has called much of the enterprise into question. Diederik Stapel, Anil Patti, and Wang Wusuk are just a few of the recent scientific offenders who've made headlines. There's also been a significantly increased media attention to scientific malfeasance with the New York Times and the websites Retraction Watch and the now defunct Science Fraud that follow every journal's correction and retraction with a somewhat breathless reporting style. And I admit that I'm not beyond the rubbernecking. I get the RSS feeds. I read the coverage as well. This increased attention to scientific fraud has therefore necessitated an increased level of scrutiny at the journal. Journals can no longer act as though all data that we receive is unimpeachable. As we have to stake our journal's reputation on the quality of the articles we publish, we therefore need to verify the veracity of what we publish. What I want to show you are some of the methods that the journal I represent here today, the Journal of Clinical Investigation, has used to verify what we publish. Many of the policies and procedures we put into place are designed to find errors that have been introduced, some by design, some by carelessness, before they are published. Other procedures were developed to be reactive to the different ways that people have managed to get around our earlier imposed roadblocks. First, let me mention that in 2013, the JCI received nearly 4,000 new publications, new submissions, and subsequently published 410 articles. We screen only those manuscripts that have been accepted for publication. During the process of preparing manuscripts for print and online publication, we gather the high-resolution original versions of all figures and display items. We test the text for plagiarism. We use tools from the Office of Research Integrity to determine which figures have been manipulated. Just to make sure that we're all on the same page in terms of science, I'm sorry this is not going to project particularly well over there. I want to sort of start out by explaining Western blots. This is a tool that scientists use to measure protein. In this example, what I'm showing you here, the different columns correspond to different test conditions, and the row or protein of interest is at the top, with a so-called loading control in the lower row. The loading control is a smaller, irrelevant protein, in this case alpha-tubulin, whose relative amount would remain consistent regardless of the experimental condition. A loading control allows you to verify that the same amount of protein is put into each lane, as if the relative amounts are different in that row, you can tell what the different amounts of protein were put into the column to begin with. We use a set of tools from the ORI to screen these images. These tools can detect abrupt changes in background or pixelation. What was not appreciated in the original version at first glance is that there's a splice between two of the columns, and yet there is no splice in the loading control. Therefore, these two rows could not have matched in terms of the experimental conditions. In this next slide, perhaps you can appreciate better on this monitor than that there's two further examples. Even without the ORI screening software, you can see two of the columns were pasted on top of the underlying bands, and on the far right, the same lane was pasted over the background 3 times. In the lower example, you can see that all the lanes have been pasted together, but what you might not appreciate at first glance is that the same lane was used 3 times. Splicing lanes together is, in and of itself, not always a crime. There are times that a set of examples that's irrelevant to the overall experiments are run in between the actual lanes of interest. On this slide, you can see columns and rows with a space in between them, or a line indicating that there were columns that were removed. We also asked authors to make a note in the figure legend indicating that the splice lanes were non-contiguous, but from the same blot run at the same time. Given how much time we spent policing the splicing of these immunoblots, we introduced a policy that every article that's submitted in revised form must also upload a supplementary file for the editor's eyes only that contains the full uncut film of the blot featured in the figure. The supplement must make clear where the lanes originated, as you can see in this example. This apparatus also allows editors to investigate and make sure that what we see in the final figure is verifiable. This practice has cut down on the number of queries we've had to make after a manuscript is accepted, and happily has reduced the amount of time between acceptance and publication. This step discourages authors from submitting something fraudulent in the first place, given that they will have to produce the originals before a manuscript is accepted. Recall, however, that the JCI encourages revision of around 430 articles a year, and this step necessitated the hiring of an additional full-time employee, in addition to the non-trivial amount of time that the editors themselves have to spend looking at these figures. Focusing on integrity has its costs. The ORI software is also useful in detecting edges and figure manipulation in images. In this example, you can see how an author tried to obscure red or green areas of intensities in these cells. The ORI filters allow you to see at a glance when someone has used the erase tool. Abrupt pixelation changes are immediately apparent. Unfortunately, the ORI tools cannot catch everything, and some instances of manipulation are only caught later. A concerned reader pointed out this issue to us after the article had been published. The authors clearly used different portions of the exact same fields to represent different conditions. After an extensive investigation conducted by their university, the article was retracted. In cases like this, where the figure manipulation was deliberate and extensive, we must refer these allegations to the author's institutions. Journals do not have the resources or authority to conduct investigations from afar. However, I do agree with Dr. Mason's earlier contention that some institutions provide a whitewash versus others that provide a very comprehensive report. We take their findings into consideration when we are making our final decisions about correcting the scientific record. I want to make sure to mention that not all misconduct or fraud we monitor is related to doctored data. For example, there are countless disagreements about authorship, and we will only agree to publish once all authors have agreed on an author list and an order. And when there are disagreements, we ask the authors to sign a document with the final title and author list that they themselves have negotiated. Speaking of authorship, this manuscript was retracted when someone listed as an author indicated that the first time he saw this manuscript was when it was published on our website. The senior author had never asked for permission to use the mice generated by the other author, nor had he filed a materials transfer agreement or made other arrangements. Additionally, the senior author forged the other author's signature on our copyright transfer form that we were using at that time. He assumed that the other author would be proud and happy to have a JCI article. Since that point, we've moved to a system wherein each author's email is obtained at the time of submission, and all are contacted to indicate a manuscript has been submitted on which they are an author. Notification also happens again at the revision phase, and if the manuscript is accepted, each author must then electronically sign a form transferring copyright and indicating that their portion of the work was done ethically and in keeping with the JCI's editorial policies and practices. We often use the fact that authors have agreed to our editorial policies and practices to broker other disagreements that arise after publications, disagreements that also fall under the purview of responsible conduct. One prerequisite of publication is that authors must make available, at cost, any newly discussed reagents, construct, or animals that are discussed within the publication. If they do not, we have often had to threaten withdrawal or retraction until compliance is achieved. We also require that the structure of any newly synthesized compounds used in the manuscript be revealed. Clinical trials data must be deposited in clinicaltrials.gov, and any microarray data needs to be entered into a Miami-compliant database. Failure to disclose conflicts of interest has also arisen on multiple occasions, and after the fact, corrections must be made so that the readership can appropriately interpret any conclusions given in a particular study. Problems with disclosure also led to the retraction of this article. Soon after publication, the IACUC, or Institutional Animal Care and Usage Committee, from the senior author's institution, contacted me to ask for copies of the original manuscript, of the original submission of the manuscript, as the author had been on probation for mistreating his experimental animals and was not authorized to do the experiments that were listed in the published manuscript. In fact, there was a full expose within the Seattle Times that came out coincident with the report that the university gave to the JCI. The author had made a declaration of IACUC approval within the methods section, and we trusted that it was in earnest. Given this unfortunate incident, we introduced the policy that submitting authors must specifically click on a button that is otherwise set to no when we ask them if they had their experiments approved by an institutional review board or an IACUC, such that we specifically have their agreement, and we also list a field for them to give a declaration. Here you can, on the lower portion of the screen, you can see the screen that we use at the JCI for tracking manuscripts. You can see the indication of approval take center stage in red, and I also put in an arrow so you can see where these authors uploaded their full uncut gels on this revised manuscript. When I give talks about preparing manuscripts for maximal impact, I often end with stridently worded advice to keep data safe, to keep lab notebooks updated, and to save copies of well-labeled figures in multiple places. Excuses of lost USB drives, laboratory moves, and labeling errors are the modern-day equivalent of the dog ate my homework and are not acceptable in today's digital age. I also advise PIs regularly to look at lab notebooks, verify every data point themselves, and sometimes ask a second person to verify experiments independently. As scientists, we're trained to be meticulous, to use proper nomenclature, to dot every I and cross every T when we're designing experiments, and PIs must remain vigilant and meticulous about the data that goes out under the name once that hypothesis has been proven. And the journals, too, must take pains to verify that what we publish is credible. I hope you're able to appreciate what the JCI, at least, is doing to ensure that our content is trustworthy. Thank you.
Thank you, Dr. Neill.